Okay, module 11.3, solving radical equations. So when we solve these equations, we need to double check and make sure we don't have any extraneous solutions. I've got 6 examples we're going to work through. Some are square roots, some are written in rational expressions, and some are cube roots, and some are written, again, with the cube root rational expressions. So, to start with, we want to make sure that when we do these problems, everything we do is balanced. So we're going to treat them like solving regular equations. So we want to get the actual square root symbol by itself. So we want anything on the outside. It's okay if it's on the inside, but anything on the outside needs to be stripped away. So we're going to subtract 2 both sides here. I get the square root of x plus 10 equals x minus 2. Now, that the radical is by itself, I can get rid of the radical by squaring both sides. Here, this is easy. I get x plus 10. Over here, I actually need to remember x minus 2 times x minus 2 is what that means. So when I FOIL that out, I get x squared minus 2x minus 2x plus 4. Now, since it is a quadratic, I need to set it equal to 0 by subtracting the x and the 10 to both sides. So this side I get 0, I get x squared. Now I know I only subtracted it over, but I'm going to combine all these x's. So minus 2x minus 2x minus x is a negative 5x and a minus 6. Now I need to factor. So I know I need a plus and I know I need a minus because it's a negative back here. Factors of 6, 1 times 6, 2 times 3 that subtract to get 5 is the 6 and the 1. And I set each factor equal to 0. So x equals negative 1, x equals positive 6. And we're done, except for we do need to check to make sure if we have a extraneous solution. So we want to go back to our original equation. We're going to check both these answers. So 2 plus the square root of negative 1 plus 10 equals negative 1. So that's 2 plus the square root of 9 equals negative 1. The square root of 9 is 3, so 2 plus 3. Guess what? That doesn't equal negative 1. So this is an extraneous solution. We do have to check the other because there are going to be times where one works and the other doesn't, or both of them could not work. So instead of negative 1 here, we're going to put in the 6. And we're going to check. So here, 6 plus 10 is 16. And this is supposed to be a 6 over here. And the square root of 6 is 4. 2 plus 4, yes, that is 6. This one works. So we actually, even though we had 2 answers to the problem, only one of them works when we plug it back in. All right, so we're going to look at our next example, number 2. And it looks a little different because we've got rational expressions. We need to get them alone on each side. So we're going to add this one to the other side. We have x plus 6 to the 1/2 equals 2x minus 4 to the 1/2. Now, I don't want to rewrite these as radicals. I am simply going to raise them both to the power of 2. Because I can do that. As long as I'm doing the same both sides, it's all legal. And when I do that, I just get x plus 6, because 1/2 of 2 is 1, equals 2x minus 4, because again, 1/2 of 2 is 1, and anything to the first power is just itself. And we're just going to solve. It's a linear, so I can add the x, or subtract x both sides. I get 6 equals x minus 4, and then add 4 both sides. So x is 10. Now, I need to go back up to my original equation and make sure it still works. So that's 10 plus 6 to the 1/2 power minus 2 times 10 minus 4 to the 1/2 power is supposed to equal 0. So that's 16 to the 1/2 minus 20 minus 4, 16 to the 1/2. Well, yeah, anything minus itself is going to be 0. So it checks, we're good. All right, moving onward. Number 3 up at that top. We need to get this radical here by itself. So we are going to add the 2 to both sides. and I get x plus 5 to the 1/2 equals 3. Now, to get rid of that 1/2, I'm going to raise it to the power of 2. This side, 1/2 of 2, that just cancels out, so we get x plus 5 on there. But this side, I don't have the 1/2 power, so 3 squared is 9. Now, I have x plus 5 equals 9, very simple linear equation. Subtract 5 both sides, and we get x equals 4. And again, we need to go back and check to make sure it works in the original equation. So 4 plus 5 to the 1/2 minus 2 is supposed to be 1. 9 to the 1/2 minus 2 is 1. The square root of 9 is 3. Minus 2, that's 1. It checks. We're good. Sometimes they'll work, sometimes they won't. You really do have to check all of them. Now, cubics. So we're going to subtract the 7 both sides because, again, we need that radical by itself. Cube root of x plus 2 equals -2. And we need to cube root both sides. Or not cube root, sorry, cube both sides to get rid of the root. So I have x plus 2 equals -8. Subtract the 2 over, and x equals -10. The nice things with cubics is we won't run into the extraneous solutions because you can take the square root of a negative. But we are going to check it just to make sure we don't have any mistakes. That's -10 plus 2 is supposed to equal -2. So let's see, -10 plus 2, that's this cubed root of -8. Yep, that does equal -2, so we are good to go. All right, last two problems that we're going to go over. This one, the cube root is already by itself, so we are going to cube both sides. Yep, you heard me, cube it. And yeah, we're going to have to do a little work with this one. So, cubing both sides is not so much fun. The left side is easy, we get x minus 5. But on the right side, that is x plus 1 times x plus 1 times x plus 1. We need to do some math. And we're going to have to multiply it all out. I'm going to use some scratch paper so that I can save some space. And I'm going to make my little scratch paper right here on the side. I need to multiply x plus 1 times x plus 1 times x plus 1. Now, you can only multiply 2 of them at a time. So we'll multiply the first 2. We're going to FOIL, so that's x squared plus x plus 1. I'm going to simplify my combined like terms, so x squared plus 2x plus 1 times x plus 1. And again, I'm going to distribute this through. So there's x cubed plus 2x squared plus x. And now I'm going to multiply everything by the 1. X squared plus 2x plus 1. And I'm going to simplify combining like terms. So I get x cubed plus 3x squared plus 3x plus 1. So here I have x minus 5 equals x cubed plus 3x squared plus 3x plus 1. It is a cubic. I do need to set it equal to 0, so I have to subtract the x and add the 5. Now, I want to try factoring by grouping because it looks like I might be able to do that. So I'm going to go ahead and set it up into the boxes. That's x cubed, 3x squared, 2x, and 6. Looking this way, these have an x squared in common. Looking this way, they have a 2. Looking downward, they have an x, and looking down this way, they have a 3. So I was able to pull things out. That gives me x squared plus 2x plus 3. Now, set each factor equal to 0. So x plus 3 equals 0. X squared plus 2 equals 0. This one's easy. X equals -3. Over here, I get x squared equals negative 2, which means x equals the square plus or minus I square roots of 2. And that's a big value. They are not real answers. So these actually get tossed as extraneous because they're not real answers. So the only answer we really care about in this problem is the negative 3. It's the only one that's real. Anything that comes up to be non-real, we don't have to worry about. It becomes extraneous. All right, last example that we're going to talk about today. We're going to divide by the 2 because the 2 is on the outside. So I have x minus 50 to the 1/3 equals negative 5. To get rid of that 1/3, I'm going to raise it to the power of 3. This side they cancel. I get x minus 50 equals negative 125 because negative 5 to the 3rd power is negative 125. Add the 50 both sides, and x is equal to negative 75. Now, I do want to go back and check my answer. I know I didn't check it on the last one, but quite honestly, when you're dealing with the cubics, checking the answers for non-extraneous is not important. It will tell you if you got the right answer or not. The only time we'll end up with extraneous with cubics is when they're non-real. But the negative 75 does work. You can check it on your calculators. Take good notes. Write any questions that you might have down. We'll discuss tomorrow.